As you work through the problems where you're finding the area of regions between curves, there are three words that I think will be helpful for you to think about. And those three words are slice, approximate, and integrate. Okay. Actually, if you'll get in the habit of thinking about those three words, that's going to actually come in pretty handy for other things that we do in Chapter 6 as well. So to talk about how you apply slice, approximate, and integrate to a problem like this. Say we need to find the area of the shaded region that's trapped between the curves f of x and g of x on the interval from a to b. You first draw a slice somewhere on your curve that is typical of every slice. Okay? In other words, no matter where I locate that slice, and the size of it would need to change, but whatever function determines the top of that slice and the function that determines the bottom of that slice remain constant. So f of x is always the top, g of x is always the bottom, no matter where I put that. And then we're going to approximate the area of that slice. We're going to sort of imagine that it's a rectangle, and the area of that slice would be the function f of x, the top, minus the function g of x, the bottom, and then that gives you the height of your rectangle, and then the width, just like the width of the rectangles that we were working with earlier, is delta x. The width of your slice is always delta x. So we have drawn a typical slice, we have approximated the area of that slice, and then the third step is to integrate that over the interval in question. So the area of our region would be a definite integral from a to b of f of x, the top, minus g of x, the bottom, times dx. So if I'm going to generalize this, area is a definite integral from a to b of the top function minus the bottom function times dx. Now you're going to see some regions that a vertical slice doesn't work for you. If you have to do a horizontal slice, all right, so this is for a vertical slice. Horizontal slice would be a definite integral from a to b of the right minus the left dx. Okay, so let's look at an example. We need to calculate the area of the region bounded by the line y equal x and the curve y equal x squared minus 2, which would be this space here. Now you're going to need to know the intersection points where the line and the curve intersect, so you can calculate those points. This point is 2, 2, and this point is -1, -1. Now, when you do a problem, I need you to first sketch the region in question and show it to me. Label any intersection points that are necessary, or label on your x-axis the lower bound and upper bound of a definite an interval, a closed interval that you're given to work with. Then on your sketch, I want to see a slice. You look at that slice, and the approximate area would be the top of that slice minus the bottom of the slice times delta x, or you can go ahead and write that as dx if you'd like. And then we're going to integrate that you think about the limits. How far left can that slice move? Well, it can move as far left and stay within the shaded region. It can move as far left as -1 and as far to the right as +2. It's the x coordinates of our intersection points. So we'll integrate from -1 to 2. And I'll leave that work to you, but you should find that is 4.5. So the area of the region bounded by y = x and y = x² - 2 is 4.5.